All right, thank you very much. I apologize. My colleague here was asking me if the presentation was going to be in English or in Italian. Well, I'm Spanish, so I'll do it in English because my Italian is not so good. The name of our presentation, I think it fits very well after the presentation of my colleague that does CNC machines, high-precision CNC machines. We're going to focus in what is metrology inside of the machine. Okay, so the title was M3MH on-machine probing software. I'm here representing INNOVALIA METROLOGY. INNOVALIA METROLOGY is a company based out of Bilbao. Well, not in Bilbao directly, but close to Bilbao, in the outskirts of Bilbao, in the middle between Bilbao and Vitoria. And what we do there is metrology, and metrology oriented to machine tools. Why do we say on-machine metrology? What does it mean? What do we do? So I'm going to start a little bit backwards. And instead of starting with calibration and integration, I'm going to show you what we do in terms of software and why we think we are doing something different to others. One of our modules as we do our product and we help our clients is how can we improve the workflow we have right now in terms of CAD/CAM design and machines. And is there anything we can improve? Can we actually increase the feedback in between different processes? How do we give eyes to the different steps? And I think that's the gap that we are trying to close together. Is there a space for what we call CAM metrology in the digital workflow? Do we need something in the middle? We think we do. What we're going to show today, and we are showing here at the show, is what does it mean and what is for us our CAM metrology on-machine metrology. What we do in here, our features, how we are not limited by my controller, my sensors, but my strategy can be open to my needs. And I have, let's see if I can point out here, features that we are showing that we can do on a machine. So we are opening a little bit the spectrum of what you think you can do. Please, gentlemen, come in. It's going to be 5 more minutes, so we will show you what can we do for you. CAD programming, GD&T, multi-geometry. We are not limited by the probe you have. So we are not limited by the architecture of your machine, right? So I have a 5-axis machine. The probe guy tells me I cannot probe in 5-axis. That's not the case. You can, but you need software. You need knowledge. You need to know how to do it. And you need to know how to process with your controllers. And this is where we are experts with. How our post-processors are capable of doing 5-axis metrology in any controller you have. And here we are mixing any type of probe or sensor optical contact. And we can interface directly, and then we can program this to the level of automation you need. So we can go sequential. You can do it manually, but you can automate completely the process. And this is going to be important. So what's the goal? Why do we need metrology in the machine? Why do I need metrology on my 5-axis machine, 4-axis, 3-axis? So it's going to be 3 goals. It's going to be pre-process, in-process, and post-process. So pre-process, what do we mean by that? We need to find your tool, and our colleague was showing some of the products out there where you can find your tool with high accuracy. But we also need to find my part. We need to find the part in a way that is to the level of the hardware I'm using. So in order to do that, I'm using CAM for programming my routines, how to cut my part, how to cut with my, what is the feed rate, and so on. Why am I not using CAM to find my part? Why am I not using the UCS I'm using in my CAM to find my part? And that's where we want to emphasize. That's what I'm going to show you a little video after this. So different type of alignments, different type of ways of doing my part setup. Machine compensation, automatically telling my machine where the part is. And of course, doing in-process measurements as well as post-process measurements. And this is going to be very important as well, knowing where my part is and what is the status, and how do I report this. So we have a little video. You can come to our booth, and we'll show you a little bit more how the tool performs and how we can simulate in the machine, out of the machine. This is a good example of a part of one of our clients that has no geometries. They are using an external machine to do the alignment of the part. And in this case, we are doing this alignment inside of the machine, 5-axis machine. We are creating an RPS alignment, reference point system, with 6 points that we align. We iterate up to like around 15 microns of accuracy, and then we send automatically this new tool position to the controller so that they can know exactly where to start the grinding. On top of this, I think a lot of us, me myself, I'm a metrology guy as a training. I'm an engineer, and everybody told me you cannot measure in the same machine you are manufacturing. That's not a correct approach. I think this is not what we're trying to prove today, but there is a certain amount of truth there. So what do we have to do in order to be accurate enough so that my measurements are trustworthy, that it can be I can be safe saying that what I'm doing on metrology on my machine is good enough. And this is what we are trying to show here in terms of what are the different things that they are being done today in terms of being sure that what I'm doing in my machine is correct and I can use it in my process. And I think there's been a lot of extensive work from a lot of companies and research in these three areas in terms of probing, optical contact, making probes more accurate, tool metrology, making it more accurate as well, and of course, machine characterization. This is not a new subject, it comes from very far away, but these 3 points are going to be so important for having good metrology and making even our product work perform correctly. And we start from the beginning because is this also, I try to put these 3 steps because these are the questions my clients or our clients and partners are asking when we do the installation of our solution. And we go to their house and to their home, they invite us, we install our product. And first thing that happens is we verify what they have. And we show them how to do the first calibration of their probe and how to perform with any type of probe and what are the correct strategies in order to use my probe. And one of the things that a lot of people are very, very surprised is how much I can improve just by using the right strategy in terms of how am I approaching the surface that I want to probe and how much error this non-perpendicularity to my surface is adding to my probing. So what we've done in our group is to, let's say, group all these features together and make them easy to use and easy to check. So we can check the calibration of our sphere with a higher accurate sphere. We can define what is the tool ID in my controller, how I activate, deactivate. I'm going to use one contact or I'm going to use 2 contacts. We could get into that, but on another talk about being more accurate or less accurate in the way I'm latching the position and what is the offset in my machine, what is the architecture. So what we've done here is condensate all this information in one place so that I don't make mistakes. What happens a lot of here is a lot of our clients, because it's in the controller, is in some table, is complex to configure. So on a second stage, we make the calibration of the probe using their controller, whatever the strategy it is in this case, where we go into 5-axis metrology and we see most of the things to improve is how am I characterizing my rotary axis. So the second step is I have my probe correctly. Now I want to measure in 5-axis. You say you can do it with your product. Prove me you can do it. And most of the times what happens is the machine cinematics is not correct. And it's not correct to the extent is needed for metrology. And this is going to be very important. So we need it to be even more accurate for metrology. So rotational errors or compensation are going to be super big in metrology. And here what we do is we are not doing anything other of your products have already, but we are doing it in our own interface. So we are calculating in 3-axis, 3+2, or in TCP directly in 5-axis. First your cinematics, and then we can calculate the residual errors of your machine. And these residual errors are going to be important because we can use them to compensate your measurements. So we can make your measurements more accurate. And stay with that because that's going to be key. Once you start using CAD/CAM for metrology, you want to have even more accurate results. And we are showing here this feature as well in our software that allows you to go from a 3+2 or a 3-axis kind of programming to a TCP 5-axis in like that, right? So very interesting for checking how accurate my environment is. This is more of what we do with what the results are. And then in a third stage, how do I characterize my machine? I bought the machine, I have a map error, I have my errors in the machine, and now I'm interested in knowing how to check this and if I can compensate these errors of the machine for doing the measurements. I'm not gonna be looking into compensating for machining, but looking into making my measurements more precise. And this is just an example of what we're doing here. We're using a gauge, in the 3D gauge, 4 spheres. We can measure in 5 axes in a quick way and check the accuracy of my machine, and then compensate for those 6 to 9 errors before I do the measurements. So I'm going to be a little bit more accurate than if I don't use this. So in a nutshell, I tried to summarize what we're doing here, and in terms of how do we want to fill the gap in between metrology, machining, design. A little bit, this is just an idea of how we are solving the problem, or we are giving more features to the machining guys, that they can do things in a different way without being constrained by the controller and the software in their controller. So there's another life out there, and we want to show it to you. So please come and visit us. We're still here until tomorrow afternoon. This whole F27, and I think I'm nearly up to a point, 3 minutes. So thank you very much for the guys over here, and thank you for coming.